Now let's look again at the problem of solving systems of linear equations, but let's look at a different method. And this method is called the elimination method. And here's the reason the elimination method works is because you can always add or subtract equations. And you can always multiply equations. And though we almost never do that, we always could. For example, let's say we had 4 plus 3. Well, 4 plus 3 is 7. And let's multiply everything in that equation by 10. Then you would get 40 plus 30 is 70. Since 4 plus 3 is equal to 7, if you multiply everything by 10, it also must be true. It also works when you add and subtract equations, so let's do 4 plus 3 is 7 again, and let's also do 5 plus 4 is equal to 9. Both of those are true. So let's let's add those two equations. So 4 plus 5 is 9, and 3 plus 4 is 7, and 9 plus 7 is 16. So it has to be true. And we're going to use that to solve a system of linear equations. So let's look at an example, and the first example that we're going to use is 3x plus 2y equals 8, and 5x plus 4y is equal to 14. So the steps in solving the elimination method are, the first thing that we're going to do is we're going to multiply one or both equations so that the coefficients of x or y are the same or opposites. Now, one tricky thing when you're learning this is that there's more than one way to solve this problem. We could make the x's the same. This is the coefficients 3 and 5, so we could multiply the two equations by something so those match. Or we could multiply the y's. This is 2 and this is 4. Now let's say that we multiply the first equation by 2, then that would be a 4y and a 4y, and those two would be the same. So let's do that. So we're going to take the first equation, and we're going to multiply by 2. You could do it by negative 2 as well. So that would give you 6y plus 4y is equal to 16. And then let's leave the other equation alone. So it's 5x plus 4y is equal to 14. Okay, and now if you look at the coefficients here, then in this case they're both 4, they're both the same, and that's what we want to, and that's step number 1. Step number 2 is you're going to either add or subtract these two equations, whatever makes a variable disappear. What do I mean by disappear? Well, if we add 4y and 4y, we get 8y. But if we go 4y minus 4y, then that's 0, and 0y is 0. So the y disappears. So what I'm going to do is I'm going to subtract. Now, what I do is whenever I add or subtract, I put parentheses around it, and then I make the minus sign or the plus sign really big, at least 3 times as large. And that way I know that I'm not, this just negative doesn't just go with 5, it goes with the whole equation. And then 6x minus 5x is 1x. 4y minus 4y is 0. And 16 minus 14 is 2. And then I'm simply going to solve. In this case, it's solve 4, meaning x is equal to 2. That's the end of step number 2. Step number 3 is you're going to plug the answer from step number 2 into either original equation, and then you're going to solve as well. Now, students get caught up here a little bit. You can either you can either substitute an x equal 2 into either one of the original equations or into either one of the transformed equations. It wouldn't matter. The first original equations are usually going to be a little bit easier, so I'll go 3x plus 2y is equal to 8. I'm going to plug the 2 in where the x is, so that's 3 times 2 plus 2y is equal to 8. And I almost have room here. That's 6 plus 2y is 8. Subtract 6 from both sides. And I get 2y, I'll just do it over here. Then I get 2y is equal to 2, and divided by 2 y is equal to 1. So my answers are x is 2 and y is equal to 1. Typically it's written like this, 2 comma 1. Let's put a box around it and we're done. Now, how would we check these answers? We would plug these into both equations. We can do that pretty quick. That's 3 times 2 plus 2 times 1 is 8. So that's 6 plus 2 is 8. That checks. But we have to check the other equation too. That's 5 times 2 plus 4 times 1 is equal to 14. 5 times 2 is 10 and 4 times 1 is 4. 4 plus 10 is 14. That checks as well. So that's your answer. We get that right. So what are our steps? You multiply one or both equations so the coefficients of x or y are the same or opposites. Second step is you add or subtract two equations. How do you know if you add or subtract? Whichever makes a variable disappear. In this case, the y coefficients were the same. If they're the same, then you subtract. If they're opposites, you would add. Then we solve for that, and once you solve, you plug it into the other equation. Let's do another example. This is a slightly more difficult problem because in this one we're going to need to multiply both equations. So the first thing we're going to check at is we're going to see if any of the variables are the same. They're not. So here we have two different possibilities. We could multiply the 4 and the 3 so that they match, or we could multiply the 3 and the minus 5 so they match. And it wouldn't matter which one we do. I'm going to multiply it so that the x's are the same. So I'm going to multiply the first equation by 3 and the second one by 4. I'm going to do a little bit different here. I'm going to multiply it by a minus 4. Oftentimes it's taught that way. You want to make them so that they're opposites. Multiply by 3, you get 12x plus 9y is equal to 18. Multiply by minus 4, you get minus 12x. Minus 4 times minus 5 is a 20y. Minus 4 times 19. I'm going to have to do that on my calculator real quick. That's going to be 76, I believe. 4 times 9, I'm sorry, that's not going to be right. 4 times 9 is 36. 3, 76. And that's a negative 76. Now what we're going to do is we're either going to add or subtract, whatever makes a variable disappear. Now if we added a 12x and a plus 12x is going to be a 0x, so that's going to work. So I'm going to do this here. I'm going to make a big plus sign out here. And then, so I remember that I'm going to add everything. 12 minus 12 is 0. 9 plus 20 is 29y. And 18 minus 76... Let's do that on a calculator really quickly. That's going to be 8, it's 58. And it's going to be since you're adding, it's going to be a minus 58. So then you divide by 29 and divide by 29, and you get y is equal to minus 2. I'm sorry, x is equal to minus 2. No. My bad again. Y is equal to minus 2. Let's try that one more time. You divide 29y by 29, you get y. Minus 58 divided by 29 is minus 2, so y is minus 2. So what are our steps here? The first step is we multiply one or both equations. In this case, we multiply both equations by a number so that either the x's or the y's have the same coefficient or opposites. There's a 12 and a minus 12, so in this case they're opposites. Then we're going to add or subtract. How do you know whether add or subtract? You're going to do whatever makes a variable disappear. So if it's 12 plus a minus 12, that's going to be a 0. So you get y is equal to minus 2. And the third step is we're going to plug that answer into either original equation. Now you could you could plug them into these two equations as well, but you don't need to. 4x plus 3y is equal to 6. Let's plug in y equals minus 2, so you get 4x plus 3 times minus 2 is equal to 6. And you get 4x minus 6 is equal to 6. Now we're going to add 6 to both sides. and we get 4x is equal to 12, or x is equal to 3. Your answer is 3 minus 2. We can check that really quickly. But these are the steps. Multiply the two equations so that the coefficients are the same or opposites. Add or subtract, solve, plug in. Let's check these real quick. 4 times 3 plus 3 times minus 2 is 6. That's equation number 1. That's 12 minus 6 is 6. That works. Equation number 2. Remember, you have to check for both equations if you're going to check. 3 times 3 minus 5 times minus 2 is 19. Be careful with your signs here. 3 times 3 is 9. Minus 5 times a minus 2 is a plus 10. And 9 plus 10 is 19. So that checks. So that's your answer. And that's how you solve systems of linear equations by elimination method. Here are your steps right there. And we're done.